So the third presentation on development of standard mixed design procedure and performance guideline for geopolymer concrete. We know how important geopolymer concrete is now with now the eliminating some of the traditional cements. So the comprehensive approach offers a systematic framework for designing geopolymer concrete mixtures, regardless of the source of fly ash, addressing a significant challenge in existing models and paving the way for more sustainable concrete production practice, presented by Madushan Ratnayaka. I suspect, I assume it's Chamila, Dr. Chamila, student, and Professor, you know, student, you're a student. Chamila is here. I thought because of all your good work on geopolymer concrete. So.
Today, I'm going to draw your attention to an important aspect of which concerns each and every one of us, which is the environmental impact of construction industry. So, concrete is the second most used material in the world after the water. So, with 4 billion tons of cement used every year to produce concrete. With that, the environmental implications are very substantial. If you go with that, people have tried to find innovative solutions. For example, they have tried to find geopolymer concrete, and then they develop several mixed design approaches and so on and so forth. So with the cutting edge technology, they were able to identify with the cutting edge technology like scanning, electron microscopy, X-ray diffraction, they were identify the behavior of geopolymer concrete in greater detail. So they and also they have developed several mixed design approaches which they were able to predict the compressive strength of geopolymer concrete. So what the most problem is the when they face a new type of fly ash into their approaches, it will fail to predict the compressive strength very accurately. So this is where our research come into place. So what we are going to do is we will extract the data from the literature, and we will do some pre-processing, and we will use them into a machine learning model which will predict the compressive strength of geopolymer concrete, and also we will convert it to a mixed design approach. So basically this is our approach. So once we do that approach, it will be easy for the industrial people to use this approach. What we're doing is we will develop an interface which is easy to use for any people who don't have a machine learning knowledge at all. So this is how we're going to do the research. By doing that, we can save material, time, and the cost which we will be using for the laboratory experiments. And also our research focusing on not only the mixed design guideline, but also we are going to extend that to the predicting of split tensile strength, flexural strength, and elastic modulus of geopolymer concrete, which is very substantial parameters for structural designing. So with that 4 parameters, structural engineers can easily design the structures. We hope that it will make a good path for the industry. So if someone has a concern about how practical this geopolymer concrete is, the history has revealed that the material that they have used as the binders in the Egyptian pyramids, they are closely resembles with the material of alkali actuator that we are discussing today. So the history has give a proven result about the strength and the durability of this alkali actuated material. So finally, what we are going to do is we will do a sustainable development using this geopolymer concrete material. Thank you.
Thank you very much, Madushan. It's an excellent presentation, and you're covering an area where I know a lot of pioneering work done in RMIT on geopolymer concrete, but taking it because at the moment we know the applications are all about so-called low-grade applications, where but you are taking that to a structural level, which is quite important. So we all have to be really thanking you and for that excellent presentation, and you and the supervisors. Any online questions for Madushan?
What's the best way to collect data for your research if the final literature data is not enough? So if you find the literature data is not enough.
Yeah, the best thing is first we will collect them as much as possible from the literature, and then we will filter out based on our criteria. That means if we're using class F fly ash for geopolymer concrete, we have to filter them based on that criteria. Then if we don't have enough data, we have to go for experimental studies, and we have to conduct some experiment in the laboratory to acquire new data for our modeling.
Thank you.
And how far have you progressed?
Yeah, for the moment, we have already developed the predictive model for compressive strength, and it's been validated with the testing laboratory experiments. Up to 95% accuracy, we can predict the compressive strength up to now. And the next step will be we'll be expanding our model to incorporate that mechanical performance parameters like flexural strength, split tensile strength, and elastic modulus of geopolymer concrete.
Thank you very much. And what sort of strengths, just to extend that question, but what sort of strengths you are looking at
For the
to
moment,
cover?
we have considered about 25, grade 25 to 55, around
Very
55.
good, yes.
For the 55, we were able to achieve around 60 MPa.
Very good.
So
yes.
that's the best that we can achieve
And it's
at the moment.
ordinary curing, just
It's a heat curing
heat
process.
curing,
Yeah,
up
heat
to which
curing process.
temperatures you?
Mostly it is range between 60 to 80.
Okay, very good. And you're just fly ash slag based as well, or?
No, only the fly
I know it's too
ash.
much for this
just fly
PhD.
ash, yeah.
Maybe another PhD for that, but it's too much.
So we are planning on also blending those two fly ashes. So since we
very
are going in detail, so we can blend two fly ashes and improve the quality of the geopolymer.
Excellent. That is very, very good work. Any questions from the audience? Yeah. No. So anyway, I'll probably just to keep the discussion going. But in terms of the flexural strengths and all that, so idea is that you will try to match the. So actually, as you know, it's from as a code committee TS 199 we published a couple of months back, which will we call it alkali activated materials. So that brought some other the design parameters. I'm sure you'll be working with some of those to improve those parameters, where we suggested some low density geopolymer or alkali activated and high density. We classified into two. So what are your findings up to now showing any comparisons with the present concrete? Is that an idea that you will be?
Yeah, at the moment, what we have already checked only the compressive strength parameters in order to validate the first model. So we are extending it up to incorporate the flexural strength and split tensile strength, elastic modulus like this. We are going to extend it to that level.
Thank you very much. That's excellent work. Again, I think we had to thank if there are any other questions. But I think this will make a big contribution to we have to get the geopolymer concrete into the practice to really get to that net zero, as we know. So it's interest already being generated. So it'd be excellent work. So can we show our appreciation?